Michael Burry is betting against the AI boom, and this time he's put real money behind it. His hedge fund's latest SEC filing shows over $1 billion in put options against Nvidia and Palantir. That's roughly 80% of his reported portfolio wagering that AI stocks will fall. A caveat, 13F filings only show one side. Burry could have offsetting positions elsewhere. But when you publicly call out hyperscalers for what you describe as accounting fraud, you're not hedging, you're making a call. The investor who predicted the 2008 financial crisis has accused hyperscalers of artificially inflating earnings through aggressive depreciation accounting. His claim, tech giants are stretching GPU lifespans from 2 or 3 years to 5 or 6, understating costs by what could amount to $176 billion through 2028. Whether you're an investor navigating AI valuations, an engineer working with this infrastructure, or an executive making strategic decisions, this matters to you. Let me walk you through Burry's actual model. He's built his on 7 pillars. Pillar 1, economic obsolescence trumps physical lifespan. The relevant depreciation timeline is when a GPU becomes economically uncompetitive, not when it physically fails. A chip that works but costs more per flop than alternatives is effectively worthless for its intended purpose. Pillar 2, power efficiency is the kill metric. Data center economics are dominated by power costs. When a new chip delivers 3 to 4 times more flops per watt, older chips become stranded assets even if they're still running. The power bill per unit of useful work simply becomes uncompetitive. Pillar 3, Nvidia's cadence sets the clock. The depreciation window is determined by Nvidia's release schedule, not customer preference. An architecture cycle of 1 to 2 years means each generation has approximately that long before it's displaced by something dramatically better. Blackwell is shipping now. Rubin comes in late 2026. Pillar 4, the frontier use case is the relevant benchmark. Hyperscalers bought these chips to train and serve frontier AI models. If the chips can't compete for those workloads, they've lost their economic justification, regardless of whether they could theoretically run lesser workloads. Pillar 5, asset value declines faster than linear depreciation. If you depreciate a GPU linearly over 6 years, you're expensing 1/6 of its cost annually. But if the chip's economic value drops off a cliff after year 2 or 3 due to obsolescence, your depreciation expense is too low in the early years. You're not recognizing the true cost of using the asset. That means earnings are overstated upfront. Later, you're left carrying an asset on your books at far more than it's actually worth. And eventually you face a write-down. Pillar 6, depreciation extensions are financially motivated. The shift from 3 to 4 years useful lives to 5 to 6 years happened after CapEx exploded. Burry argues the extensions were made to manage earnings impact, not because operational evidence supported longer lifespans. Pillar 7, cascading use cases don't scale. The counter-argument is that chips cascade from training to inference to smaller models to other workloads. Burry implicitly assumes this demand pyramid doesn't exist. There aren't enough second-tier use cases to absorb the 400 billion of demoted GPUs. This is his bear case. Hyperscalers face massive write-downs when the depreciation mismatch becomes undeniable. But here's what's curious about actual bet. If the thesis is right, if GPUs really do become obsolete in 2 to 3 years rather than 6, hyperscalers need to replace hardware more frequently. That means more chip purchases on short cycles. Nvidia should benefit. Yet Burry is shorting Nvidia. There are a few ways to read this. Maybe it's a valuation bet rather than a business bet. Nvidia's fundamentals could be fine, but the stock is priced for perfection. Maybe expects demand destruction. If hyperscalers realize they've over-invested in hardware that depreciates too fast, they pull back CapEx entirely. Either way, the Nvidia short doesn't align cleanly with the depreciation thesis. That's worth noting. Now, here's the Steelman case against Burry. The cascading use model isn't theoretical. It's documented operational reality. Year 1 to 2, frontier model training at its highest margin. Year 2 to 4, production inference for deployed models. Year 4 to 6, smaller model serving, fine-tuning, cloud rendering, batch processing. A GPU used exclusively for frontier training at 60 to 70% utilization legitimately warrants 3-year depreciation. The same GPU cascading through inference, then smaller model serving, then cloud rendering over 6 years also legitimately warrants 6-year depreciation. Its economic benefit period genuinely extends that long for that specific hyperscaler's business model. This isn't accounting manipulation. Both GAAP and IFRS explicitly accommodate it. And here's where the market evidence contradicts Burry's obsolescence thesis. CoreWeave CEO Michael Intrator stated publicly that A100 chips announced in 2020 are fully booked. A batch of H100 chips from 2022 became available because a contract expired. They were immediately booked at 95% of their original price. His words, all of the data points that I'm getting are telling me that the infrastructure retains value. If 5-year-old chips are still fully utilized and nearly new chips rebook at 95%, the 2 to 3 year cliff isn't showing up in actual transactions. CoreWeave's customers include OpenAI, Microsoft, Meta, IBM, and Mistral AI. These aren't marginal players running outdated workloads. The inference demand argument is crucial here. Training requires cutting-edge hardware, inference doesn't. As AI deployment scales, the ratio of inference to training compute is shifting dramatically. Jensen Huang at GTC 2025 described the compute requirements for agentic AI and reasoning models as orders of magnitude beyond what anyone anticipated a year earlier. This creates massive demand for good enough inference hardware, exactly what older GPUs provide. The A100 isn't competing with Blackwell for frontier training. It's serving a different, rapidly growing market. Demand for inference outstrips supply. Older GPUs remain useful for inference long after they're obsolete for training. What about power efficiency? Yes, newer chips are more power efficient per flop, but electricity typically represents around 15 to 25% of operating costs, though this varies significantly by facility. According to Funder Said Energy's analysis, uptime and utilization have around 5 times more impact on overall economics than electricity prices. The directional logic is straightforward. Utilization is how much of your hardware's capacity is actually doing useful work. High utilization means your CapEx and rental spend is being sweated properly. Low utilization means you're paying for silicon that spends its life staring out of the window. Uptime is whether the hardware is available at all. Every hour of downtime is an hour where your capital investment generates zero revenue. A drop in utilization hits your entire revenue line, but a rise in electricity prices only moves a slice of your OPEX. This is why operators don't just rip out working hardware just to save on power. They run it until it breaks or demand disappears. The stranded asset scenario assumes operators would voluntarily decommission functional revenue-generating equipment. In practice, the economics don't support that. Let's look at what hyperscalers have actually done with depreciation. Amazon extended server useful life from 4 years to 5 in 2022, then to 6 years in 2024. That extension saved them $900 million in Q1 2024 alone. But here's where it gets interesting. In early 2025, Amazon reversed course for AI-specific hardware. They shortened depreciation from 6 years back to 5 years, taking a $920 million accelerated depreciation charge. They also retired some equipment early. That's significant. Even the hyperscalers themselves are recognizing that AI hardware evolves faster than their original estimates. So what happens from here? A few paths stand out. If inference demand disappoints and agentic AI proves slower to scale, the demand pyramid inverts. Too many frontier chips, not enough second-tier workloads. Hyperscalers face write-downs starting 2026. If inference demand explodes, as Huang predicts, Older chips cascade perfectly. The 6-year depreciation becomes conservative. Neoclouds like CoreWeave absorb surplus capacity. Most likely we land somewhere in between. Some write-downs materialize for marginal players. CoreWeave faces scrutiny first. Management reported 1.9 billion in quarterly capex against 1.36 billion in revenue, with 14 billion in total debt. Their 2026 capex is projected at more than double 2025. But hyperscalers with diversified workloads and locked-in power contracts extract genuine value over extended periods. GAAP requires companies to depreciate assets over their expected useful life, but it explicitly makes this the company's responsibility to determine, considering the technological obsolescence and economic factors. Companies must convince auditors using engineering data and internal analysis. Microsoft, Meta, Amazon, Alphabet have all done exactly that. Big Four auditors sign off. The accounting standards intentionally allow the same asset class to have different useful lives depending on the operator's business model. So, how do you actually track whether the bulls or the bears are right? This is difficult to do. The cascade thesis lives or dies on inference demand. If inference scales, older chips stay economically useful. If it doesn't, Burry wins. Perhaps a proxy measure we can use is monthly active users on AI-powered applications. ChatGPT, Claude, Gemini, Copilot. Every query from every user is an inference workload running on a GPU somewhere. When OpenAI reports hundreds of millions of users, that's hundreds of millions of inference requests, keeping older hardware economically viable. Watch the growth curves. If monthly active users plateaus, inference demand may also be plateauing, and the cascading breaks down. There is one exception here, that inference demand also is a function of agent complexity. So you can, in theory, have the same monthly active users running more complex workflows, which would also scale inference demand. For infrastructure players like CoreWeave, there's a specific metric worth tracking: their revenue to capex ratio. Right now, they're spending more on infrastructure than they're earning in revenue. That's normal for a growth phase company building out capacity. But if the cascade thesis holds, if inference demand keeps older GPUs economically useful over 5 to 6 years, we should see that ratio improve over time. Revenue climbs as contracted capacity generates returns across multiple years. CapEx eventually stabilizes as the installed base matures. If the ratio keeps deteriorating, if they have to keep spending aggressively just to stay competitive because older hardware becomes worthless, that's Burry's thesis playing out in real time. If you're an engineer or a technical leader, the implication is clear. The companies that win will be the ones that extend the economic lifespan of their inference hardware. That means investing in R&D for more efficient chip utilization, software optimization that squeezes more useful work out of existing silicon, workload scheduling that maximizes throughput without requiring the latest architecture. The hyperscalers are already doing this. Amazon explicitly cited software refinements as justification for their depreciation extensions. The engineering challenge isn't just building for the frontier, it's building systems that keep generating value on hardware that's 3, 4, 5 years old. That's where the leverage is. Hardware improves faster than accounting conventions can track. Nvidia ships new architectures roughly every 1 to 2 years. Hyperscalers depreciate over 6 years. Burry's concern has merit, but his characterization overstates the case. Market transactions suggest extended useful lives aren't fiction. CoreWeave's 95% rebooking rates and fully utilized A100s are real data points. Amazon's 2025 reversal is worth watching. They're adjusting their estimates in real time, which suggests they're taking the risk seriously. Track inference demand, watch revenue to capex ratios.